All right, this is lesson 7 for chapter 2, rational numbers. So we are starting to look at square roots of rational numbers. Those of you from last year should remember when we did chapter 3 Pythagorean theorem, we talked about perfect squares, we talked about non-perfect squares, we talked about rectangles, and I really hope that you remember the difference between perfect squares, non-perfect squares, and rectangles. We did a Venn diagram even about them. And we talked how just because something isn't a perfect square doesn't make it a rectangle. Non-perfect squares are still squares, meaning they have 4 equal sides, but those numbers aren't whole numbers. The side lengths aren't rational numbers. And so we're going to look at some of those examples today. I would suggest, before you start this chapter, or pardon me, this section, that you remember what the perfect squares are. So 2 by 2 is 4, 3 by 3 is 9, 4 and 9 are our perfect squares. You might want to make a little cheat sheet for this. We might make one in the class as well, but it would be helpful for you to have. It might even let you use it on things like quizzes and tests. So our first couple examples are, we're going to look at prime factors. So if you remember what prime numbers are, so 1 is a prime number, 2 is a prime number, 3 is a prime number, 4 is not a prime number. 5 is prime, 6 is not prime, 7 is prime, 8 is not, 9 is not, 10 is not, 11 is prime. So when we're thinking of prime numbers, we're thinking of numbers that only can be made by multiplying 1 by themselves. So 9 is not prime because 3 times 3 is also 9, as well as 1 times 9. But 11 is prime because the only way we can make 11 is 1 times 11. So prime and not prime numbers. So we want to split these numbers into their prime numbers. So the easiest way to do that is to make a factor tree. And factors are things that get multiplied. Please don't add for your factor trees. So 36, first one I think of is, well, 36 is a even number, so I can divide it by 2. And we get 2 times 18. 2 is prime. I'm going to circle it. I'm going to split up 18. 18 is also even, so I'm going to divide it by 2. And we get 2 times 9. 9 is not prime. We can get it by 3 times 3. And 3 are prime numbers. So the prime factors of 36 are 2 times 2 times 3 times 3. Okay? I hope that you notice that we have 2 equal groups. So we have one group, 2 times 3, and we have a second group, 2 times 3. Okay, so 36 is a perfect square, and it's 6 times 6. Okay, if we look at 45, I have to erase this so I have space. 45 is not an even number, so I cannot divide it by 2. I could divide it by 3, I could divide it by 5. Both of those are prime, so it doesn't really matter which one I pick. I am going to pick 5, and 9 times 5 is 45. So prime is 5, and 9 again, we'll split times 3 times 3. So the prime factors of 45 are 3 times 3 times 5. You notice that we're writing them in increasing order. And we cannot make 2 equal groups of factors. I could make one group of 3 times 5, but then there's a 3 left over. Or I could make one group of 3 times 3, and then there's a 5 left over. So we can't make 2 equal groups. It's not going to work. So 45 is not a perfect square. When we look at our last example, 16 over 49, we're actually going to do factor trees for each of the numerator and the denominator. So we're going to do a factor tree for 16, and we're going to do a factor tree for 49. So 16 splits into 2 times 2, 2 times 8. 2 is prime. This splits into 2 times 4. Oh, circling the wrong one here. Try that again. 8. 2 is prime times 4, and it becomes 2 times 2. So 16 is a perfect square because we can make 2 equal groups of prime factors. 2 times 2 and 2 times 2. So we get 2 times 2 times 2 times 2. 2 over 49. 49 is a perfect square, and it splits to 7 times 7, and 7 are prime numbers. So we have 2 times 2 times 2 times 2 over 7 times 7, or we could say 4 over 7 times 4 over 7. So if you notice, we have the same fraction times itself, so this is a perfect square. So on the bottom, it says which of these numbers are perfect squares. They are all perfect squares. And we just showed why. So hopefully you remember that a perfect square is a number, not a hash, a number that can be expressed as the product. So remember, product is multiplying of two equal rational factors, or two equal rational numbers. Okay, so now that you've refreshed yourself on what a perfect square is, I would like you to figure out which of these are perfect squares. So there's a couple methods you could use. You could use our prime factors method that we just showed. You can use your calculator method of your square root button. I don't care which one you try, I want you to try them. So you're going to pause this, you're going to decide for yourself which are perfect squares, and then you're going to restart the video. Okay, so perfect squares. When we looked at these four examples, two of them I'm showing the fraction method and two of them I'm showing the calculator method. So for the fraction method, I found the prime factors of each. So 25, prime factors are 5 times 5, 49, prime factors are 49. I hope you notice that 25 and 49 on their own are both perfect squares. So when we split them up, we get two equal fractions. So this is a perfect square. If we had the area of 25 over 49, each side length would be 5/7. I know it sounds kind of weird with fractions, but that's what it would be. If we look at our second example, 0.4, if you wanted to, you could look at this as 4 over 10 in a fraction, so 2 times 2 over 2 times 5, or you could put it in your calculator, square root of 0.4, and we get 0.632, etc., etc., etc. So it's gone forever, and it doesn't follow a pattern. So that's really important. Sometimes we'll have decimals that will follow a pattern, and they technically would still be rationals or perfect squares. But this example, this decimal does not follow a pattern, so it is not a perfect square. Okay, when we look at our third example, 14 over 15, again, I put them into prime factors, so 7 times 2 over 3 times 5. We do not have two equal fractions, so this is not a perfect square. And then lastly, 1.2, again, we could have gone 12 over 10 and gotten 2 times 2 times 3 over 2 times 5. And notice that we can't make equal groups. Or just type it in your calculator and you get 1.0954. Again, does not follow a pattern, so it is not a perfect square. So that's kind of it. All right, so these equal factors are the same as the square root of those numbers, okay? Or we could say these equal factors are the same as the side lengths of those areas. So let's say square areas. So in this example, it says, given the side lengths of the square, determine the area. Well, I hope you remember that area of a square is length times width, but because the length and width are the same thing, it's actually side times side, or side squared. So we know that one side length is 2.6. That means all the other side lengths are 2.6 because it's squared. So area is 2.6 meters times 2.6 meters. So we get an area of 6.76 meters squared. Please make sure you have your units. please make sure you have the proper units, so squared. That is all the work that I'm looking to see on these types of questions. The next example, I've also given you the side length, and you want to find the area of the square. So again, area equals side squared, or side times side. So 7.1 centimeters times 7.1 centimeters, we get an area of 50.41 centimeters squared. That should be nice and straightforward for you. These last examples, so again, we're just going to calculate these, okay? So in your calculator, you're going to type square root 233. Some of you might, depending on your calculator, might have to go 233 and then press your square root button. Your square root button might also look like this, okay? If there's one that has a 3 or an X instead of the 2, don't use that one. We'll explain a little bit later what those ones are. So when I type this in, I'm going to get, I'm going to double check my rounding on here. So the answer I've written down, I don't think I've rounded it. So I get 15.264337. So this is an irrational number. This is going to be a non-perfect square because we have an irrational square root. And it says to 2 decimal places. So 15.26. The 4 tells me that it does not round up. So 15.26. When I look at the second example, again, I'm going to type in my calculator square root 1.69, or I might have to press the square root sign afterwards, and I get 1.3 exactly. So to show that that's exact to 2 decimal places, I'm going to add a 0, 1.30. The next 2 examples, I've given you the area, and I want you to figure out the side length of a square. So the side length is a number times itself, so that's also the same as finding the square root. So to go from area to a side length, we square root. So square root of 1.44 centimeters squared should give me the side length. And we get 1.2 centimeters as the side length. Second example, we're going to do the same thing. I've given you the area. So to find the side length, we square root the area. So square root 196 meters squared will give us the side length, and we get 14 meters as the side length. Okay, that's it for these examples. So tomorrow we will give these a try.